All right, welcome back, Section 2, Unit 2. Continuing on with some of the PowerPoint, we just covered metric and English conversions, ratio, comparison between two numbers, proportion is two ratios equal to each other. These are things that I would definitely put down in my notes. I would structure them very similar to what the PowerPoint looks like. This is part of successful note-taking, okay? When you're taking notes along the way, find ways to organize your notes, how they are relevant, quite possibly give yourself space in between each ones. If you need to, you can draw or present an example to help you clarify and understand as well. And then so down here again, English metric conversions, I would definitely make sure to put 1 inch is equal to 25.44 millimeters. As long as I know this value, I can find this one out. But you have to have one given value in order to work from, okay? This is your basic one that most of us will deal with from time to time. Is 1 inch is 25.44 millimeters, okay? So now we're going to move on to basic geometry. Parallel lines, surfaces never intersect. The distance between them is constant, and that is constant forever. They're exactly the same, okay? Perpendicular lines, they intersect at a square or 90-degree angle or a right triangle or a right angle, okay? And we're going to talk about circles, the diameter, the distance through the center, the radius is distance from the center to any point on any circle, and circumference is the same thing, distance around periphery calculated using pi. There are also some other formulas out there. So here's a good example of constant distance. So we're talking about parallel, okay? Parallel again means they never intersect. They are constant distance. So now if this was 2/1000ths of an inch in this direction, and I'm going to go very drastic here so we understand what we were talking about here. This one's here, and instead of being straight, it's 2/1000ths of an inch in this direction. Way down here, eventually, it will touch each other, okay? So it also depends on the size as to the sensitivity and the tolerances as well. So if we're talking about a 1 inch piece, it should be within 1/1000ths of an inch to 2/1000ths, roughly. But that is the definition of parallel, is that they are constant distance from each other, their lines shall never intersect. So to put it into, for example, this might be a 3-2-1 scoring block on a machine. These lines are parallel. These lines are parallel. These lines are parallel. Straight up and down. They should never touch, or they will never intersect each other. And they should be a constant distance from each other at all times. Okay? Perpendicular lines create 90-degree corners. So for example, you might see, like I drew earlier, a square box here showing that this is 90 degrees to each other. All right? And this is perpendicular. So if this line extended down through here, this line would also be perpendicular to here, to this line. So back to the cube, we have parallel. However, this line and this line are perpendicular. This line and this line, these two lines are perpendicular to each other as well, because this is given an isometric view, okay? So looking down from it on the end, it looks just like this. Giving us a front view, we're looking at it to where this line is perpendicular to this line is perpendicular to this. You're getting the point, I'm sure, at this point, okay? Circle, radius versus diameter. Diameter is 2 times the radius. This is your center point, always. So if this was 1 inch, your diameter would be 1 inch, your radius would be 1/2 of an inch, 0.5 inches, okay? The circumference is the distance all the way around. So real quick, one way, your radius is 2 times, so if we found out we only knew our radius showed us 0.5 inches, we could take 0.5 times 2, or 2 times 0.5, and we would end up with a 1 inch, therefore knowing our diameter, okay? So sometimes on print you'll see something that might tell you 1/4 inch radius. So if we want to figure out, say we were machining that and we wanted to do it in one pass, we could, it's 1/4 inch radius, we could take a 1/2 inch end mill, and as long as we went to the center point, we could come in there and it would be exactly, this would be our end mill. The radius of a 1/2 inch end mill is 1/4 of an inch, okay? Circumference is the outside diameter. It can be calculated by, if you were to know your radius, 2 times your radius, 2 times pi radius, sorry. So when we look at pi, there's a button on it in your calculator which you can use, and it will give you a much more accurate reading than just doing the traditional 3.14. However, pi is 3.14. So if this was 1, take 2 times 3.14, so we're at 6.28 times 1, 6.218. Or your circumference is equal to pi times your diameter, okay? Moving on. Arc is a portion of a circle. It's usually labeled by its endpoint. So there are times when machining, especially with keys or slots, you may need to find a relevance as to where point A is, point B is, and that would be the piece that you would machine flat or possibly cut down into from there. It can be expressed on an angle value as well as a point value as well, okay? Here's an arc from R to S, X to Y. As you can see, none of them are showing exactly 90-degree angles, so it's hard at this point to start with a relevance, or a relative beginning point. Usually on a print, you will be giving some sort of relevance, whether this is 90 degrees across here. I would assume that this one is at 90 degrees. You could find the length of this arc. You could also find the angles within it as well. We'll break that down further as we're moving through this course, okay? So we're going to talk about circles, continued arc, portion of the circle, we just covered that. We'll talk about the tangent, which touches the arc at only one point. Angles are created by dividing a circle 360 degrees completely. So let's break this down some more, okay? So 90 degrees is A to B. 90 degrees minus A is equal to B. So if we're only given one value and we show that this is a squared piece, and we know that angle A is 22 degrees, then we can take 90 degrees minus 22, and that would tell us that B is 68 degrees, okay? Here's another case. In this case, it tells us here, it walks us through the math problem. 30 degrees here, tells us that 60 degrees is here. We also can add these to know that these are at a 90 degrees. So this is a true right triangle. These lines are perpendicular to each other, okay? B is the supplement of A. So in this case, we have half of a 360 degrees, so we know we're 180 degrees total, okay? So A, you subtract one from the other, it equals the same value. So in this case as well, If you're only given one value, you know it's 180 degrees. You're giving one section of 95, then you know that this, by subtraction, B here is 85 degrees. Okay? Where does this come into play the most? This is probably most relevant when we start talking about bolt circles. Okay? So it's showing that all four of there are right triangles. So right now at this point, this is 360 degrees. It is broke up into 4 sections, divided by 4 equals 90 degrees, which we know because they're right triangles, right? However, we have 4 pieces of the pie at 360 degrees, now we're at 90 degrees, okay? So on our print, say we are giving 3 bolt holes at, we'll get more complex into the actual breaking down the portion. 3 holes, equally spaced, we know that, real quick, we can figure out 360 degrees divided by 3, we're at 120 degree angle on each piece, okay? So now we know from here to here is 90, and we're 120, so now we can take 120 minus 90, so we now know this angle is 30 degrees. We also know now that this angle is 60 degrees, okay? So if we know this is 60, then how do we know? We know this right here must also now be 60 degrees because, what are they? They're at 120 degrees, 3 equally spaced, so each at 120, each at 120 degrees. So we had 90, 30, so we're at 120, 60 and 60, now this is 120, and we also know at this point, this one comes back around to be 120 degrees as well, okay? Now say on the inner piece, we have 4 holes equally spaced. So real quick, $360 divided by 40 or by 4 is equal to 90 degrees. But how do we know where they're at? Okay, we don't always want to use relevance term. We know this is a 30. Again, my drawing's not to scale. Okay. One thing that we can do, I don't have one here with me. When we are looking at this, I'm going to get some pieces and I'll come back to explain this section more. Okay.